So using 1 mil of partially purified cell lysate. Okay? So 1 mil is your total amount of your cell lysate, and it contains 1 milligram of total protein in it. All right? So you can get a concentration, for this. Scatter plot is obtained. You have the following scatter plot obtained for binding of the protein FKBP to the drug rapamycin. The molecular weight of the protein is 20,000 Daltons. Daltons are grams per mole. I'm going to write that down. What is the purity of the lysate with respect to FKBP? So what this is asking you for in terms of purity is how many grams of of this protein of interest are in your total lysate. And you have a total amount, 1 milligram of proteins are in there, but not all of it is the protein of interest. Assume that this protein binds to rapamycin 1-to-1. And so it gives you the plot and it says, hint, start by getting KD, then get your P total in a concentration. Okay, you can figure out then how many grams. And again, P total here is the actual FKBP. So like I said, just sort of the hints are that purity means mass of the FKBP protein over the mass of total protein that you start with in your cell lysate. Daltons are grams per mole. But why don't you take a minute and try to calculate both KD and P total and see what you get. And then we can talk about kind of going through the rest of it quickly. This plot's kind of tiny. Hopefully you can maybe see it. Calculated dissociation constant. .02 nanomolar. Yes? Couple head nods? Okay, that's what I expect. This is the problem I'm spoiling. P total is going to be the exact same thing. All right. So let's see. All right, so I wrote down, I won't recopy this solution for the interest of time. So you have 1 milligram of total protein, 1 milliliter of total solution of your cell lysate. You were given molecular weight of your protein of interest. I told you purity is going to be mass of the protein of interest over total protein. So in part 1, find KD. You're looking at the slope. It's -1 over KD. Change in Y over change in X. Pick any 2 points you want. Make them easy. Make them round numbers. Okay? So I had chosen 0.01 nanomolar and 0.5, and 0.018 nanomolar 0.1. Okay? And if you plug this in, you should get negative 50 for the slope. So K sub D is going to be positive 0.02 nanomolar, and my units check out. Okay? For calculating P total, the y-intercept would be P total over K sub D. It's also going to be the x-intercept where it crosses that concentration. We don't have from that plot a y or an x-intercept definitively. Okay? We didn't measure concentrations with, over the full range. So plug a point back into your Scatcherd equation. Okay? So I just picked 0.01 nanomolar for L bound and 0.5 for bound over free. So 0.5 is equal to negative 1 over, here's my KD, here's my X, and I'm solving for P total. So calculate this, move it to the other side, and you should get P total is equal to 0.02 nanomolar. So it's the same, and I think this is the one where people freaked out last time. The units of concentration of molar make sense. We're talking about a concentration of total FKBP protein. Okay, remember that's the actual receptor that's being bound, okay, by the ligand in our Scatcherd plot. So we're not looking at total protein, we're looking at that concentration of protein, and it's in moles per liter. That makes sense to us. Okay, so for calculating purity of the total protein solution, first I want to determine the mass of FKBP that I have from the concentration I just got for P total. So 0.02 nanomolars will be 0.02 times 10 to the negative 9th moles over liter times 20,000 grams per mole. This was the molecular weight for this protein. Times 0.001 liters over milliliters. The reason I did that was simply because I was told I have 1 ml of solution to start with. Okay. So we had 1 ml of solution. I have 4 times 10 to the negative 10th grams of FKBP protein in my 1 ml of solution. Purity is mass over mass of total protein. This was given in the problem as 1 milligram. So 4 times 10 to the negative 10th grams per milliliter for my protein of interest over 10 to the 3rd grams per milliliter. My 1 milligram of total mass is 4 times 10 to the negative 7th. So we did a really bad job purifying. Most of our protein is other stuff in our test tube and not what we care about. Okay? Questions about how to think through that problem? I could make a plot if I was given concentrations of L bound and free. I could plot a Scatcherd plot on a homework. If I saw a new Scatcherd plot, I could get slope off of it.